Okay, so I found another PHET, which is a little more advanced, but it gets the point across. So all I need you to understand is this. Think about dissociation and pH. So what I've got right here is a pH meter, and I got water. So the ultimate goal of this video is to review different pHs of different normal substances. You know, vomit, which is a good one, soda, orange juice, blood, soap. Obviously, these are basic. These are acidic. But we're going to figure out what their pHs are. Obviously, water in this case is going to be 7. And we're just going to take a look at and see what happens. And then we're going to add water. And I want you to see what happens to pH. That's the result. Okay. So right here, water, it is what it is. So I'm not going to do every one of these. So let's start with vomit. And I love that color. So when you vomit, obviously that's acidic material that comes from your stomach called bile, B-I-L-E, which helps break down food in your stomach. When there's bacteria, your body wants to get rid of it, or virus, comes right out. Sometimes it tastes real good, doesn't it? Now, what it is very acidic is a pH of about 2. So ultimately, and tomorrow maybe I'm going to show you with acid-base neutralization how Tums, those little capsule or little pills called Tums, they're called an anti-acid. I'll show you, we'll talk about how that works with neutralization. Don't stress over, well, how does that work? Don't chill. Okay, so this has a pH of 2. So think for a minute, if I add water to it, what directly affects pH? Number of dissociated hydrogen ions. Now, what happens if I add water? Will the number of hydrogen ions forming H3O stay the same? Yes. But what do you do when you add water? You're diluting it. Do you think I can dilute it all the way up to 7? You're going to need a lot of water to do that. Because the real way to dilute it, to move it up significantly, is to get rid of those H3Os. So you'll see it better in the next one. So we're going to add water. All we're doing is diluting it, and you see we had a ½ liter. Now we have about a little more than a liter of vomit. It's still really acidic. All we did was dilute it. What you want to do to really shift the pH is get rid of those H3Os, okay? Those dissociated ions that eventually go to H3O. You want to get rid of that. That's the key. You're not getting rid of it. You may be weakening their effect a bit just because there's more H2O to kind of, dilute it. But again, the pH is still about the same. So when you add water, you're not really shifting the pH too much. What you want to do, well, we'll get to that tomorrow. So let's reset. And let's take a look at orange juice. We know it's acidic, that's citric acid in it. Okay, so it's 3.5. Okay. So this is seltzer water, by the way. Okay. All right, now I'm thirsty using all these videos. Okay. So now we're going to, again, lots of dissociation, lots of ions. Here we go. Add water. Again, we're diluting it, but again, we went from 3.5 to what, 3.87. Not too big of a shift in pH right there. Again, all you're doing is diluting it. You're not changing the number of hydrogen ions dissociated. You're changing their concentration because there's more water, right, compared to hydrogen ion. But you're not getting rid of the hydrogen ion because that really does affect the pH. Okay, let's reset that one. Let's put in chicken soup. 5.8, it's almost neutral. So here we go. I want to weaken the chicken soup. Are you going to get rid of the hydrogen ions? No. All you're doing is diluting it, okay? So let's take a look at a really strong base, drain cleaner. You ever use liquid Drano, man, that stuff is caustic. A high pH of 13. So you have a lot of hydroxide ions, right? So are you getting rid of hydroxide ions, hence reducing the pH? No, all you're doing is the quantity of hydroxide is the same, the concentration is decreasing, but that doesn't shift pH too much. So take a look. It shifts the pH a little bit, but you need to knock out those hydroxide ions. Gee, I wonder what you could use to do that. It's called a strong acid, because you know those dissociated hydrogen ions, what do you think they're going to go with? The hydroxide. That's tomorrow. Okay, so again, you can change the pH slightly by adding water. Now, could you get it down to 7? You need to add like a crap load, right? I mean, a crap load, it load of water to be able to do that. But even then, it'd be really hard to do. Again, it's my house. If I want to curse, I'm a curse. Okay. All right, here we go. I'm a savage like that, right? Okay. Oh, damn it. There you go. Okay, there's your curse. All right, let's try hand soap. Like I said, it's my house. Okay. Hand soap. Dude, don't ever, okay. Do you ever get that that dopey Bath and Body Works crap, you know, and it smells like fruit or flowers? Some ones that smell like fruit, dude, they smell so good you almost want to taste it. Okay, I don't taste soap. That's a little strange. Like, you got issues if you taste soap, for real. Well, like, once in a while, do you ever like wash your face and some of the soap gets in your mouth? No, I didn't put it in my mouth on purpose, idiots. Okay. Tastes horrible. Well, that's bases. They're supposed to taste awful, and they also feel slippery. But again, they're basic, good cleansers. So again, we can dilute hand soap, but there's hydroxide in there. We're not going to get rid of the hydroxide. We're just going to lower their concentration, but there's still the same number of hydroxide in there. Again, pH shifts later. Okay, so you get an idea. Spit. Very good. You all miss that? Oh, I mean, it's almost neutral. Again, there is some acidic material in there to help break down the food, though. Neutralize that, no biggie. Okay, let's go to a higher level. All right, now this gets confusing. Okay, so watch this. Let's do this. I'm going to look at quantity. And okay, so we're not going to use this too much. This gets a little over your head. Nothing wrong with that. Okay. So now, let's start with battery acid. Now let's start with water, because I want to show you what we got here. Water. So now the pH is 7. So now look at this. I'm not going to get into this. I mean, I don't like that it's on there. I wish they moved to the side. Oh, look at this. So, you know, these H3Os are a result of dissociated hydrogen. I don't need you stressing again over why does it form H3O? Just chill. Okay. It's a result of dissociated hydrogen and then hydroxide. So you see there's a mix in here with water. It's neutral. Okay. So now if I were to, I'm going to turn this off and I'm going to put vomit in there. Not my vomit. No, we'll do battery acid. So here's battery acid, pH of 1. So what do you think it'll look like inside? Will I have a lot of red dots, a lot of dissociated hydrogen, and like 1 or 2 blue dots? Some red dots? Like what will it look like? Let's see. Oh, obviously a lot of dissociated hydrogen ions, hence the low pH, okay? So now let's take a look over here for a minute. We have quantity right here. Let's see what happens when we add water. What do you notice? The pH is going up. Now there's a little bit of hydroxide forming because of the water. Sometimes there's like this energy where they kind of split. Again, you don't need to worry about that. That's getting a little bit high level. What do you notice about the quantity of hydronium? The H3O stays the same. What happens to the quantity of water? Goes up. This goes up slightly. So therefore, this is just getting diluted. You're not going to see a significant shift in the pH. All you've done is dilute the battery acid, but you still have a very strong acid. You still have a lot of dissociated hydrogen ions. Okay, so let's go to reset. Let's go to soda. Was that Mountain Dew? Okay, here we go. Let's go to quantity. Keep it simple. We're at 2.5 pH. Do you expect a high red dot count? Lots of dissociated hydrogen, a little bit of blue? Absolutely. Watch this. Boom, look at that. It's really strong acid, not many blues, just one. Okay. So once again, we're going to add water. Watch the number of water, and you'll get a little more hydroxide. Watch this, though. Watch the dissociated hydrogen. Stays the same. This goes up slightly because you're adding a lot of water. Sometimes, again, there's energy to maybe get another hydroxide, very minimal. But as a result, the pH shifts slightly. So again, just because you dilute an acid does not mean you are changing its pH significantly. Again, tomorrow when we neutralize, that will show you a significant change in the pH. Okay. So let's do the same thing with reset. Let's go with milk. Okay, so 6.5. So when we hit this, are you going to see much dissociated hydrogen? No, you're going to see a mix. And really, it's neutral, so there's really not that much. It's mostly water. So there's a mix there. A little bit of some, a little more red than blue because it's slightly acidic. Again, all you're doing when you're adding water, the number of red dots stays the same. Okay, what you're going to see is this number is going to go up like this. And all we're doing is diluting. pH shifts slightly. Okay, all right. Let's go to a strong base. Reset. Drain cleaner. What do you expect to see? Lots of blue dots. Not many reds, if at all. 2 or 3. High pH. Why? Because we have a low dissociated hydrogen, lots of hydroxide. What if we add water? Watch what happens. The hydroxide count goes down slightly. Oh, sorry, I'm on concentration. Excuse me. Reset that. Reset. Yeah, I was going to say I wasn't right. Hold on. So we're going to go quantity. I'm not editing this out. This video is great. Okay. It's more fun when it's live. Okay, you never know what to expect. Okay. So once again, we're same situation. Half liter pH. Okay. Add water. Watch these numbers. See the hydroxide quantity stayed the same. But the hydronium a little bit went up. Lots of water, which is neutral. Again, not a big shift in pH. Again, what you're going to see tomorrow is I want to get rid of the blue. What can I do to get rid of the blue? Add a what? A strong acid. And what are you going to make? Water. And we're going to see that tomorrow. Or no, excuse me. Oh, yeah, tomorrow for you guys. I'm making this on Monday night. Okay. Let's do blood. Yeah. Again, you don't want it to be too acidic or basic. It's slightly basic. Again, a little more blue than red. Add water. Oh, again, not a big shift in pH. So I think you guys get the idea. Okay, I want to go back to this now. Let's see what happens what happens to pH when we drain it. Let's go to vomit again. There's vomit. Now, if we drain it, what do you think will happen to the pH? It stays the same because the concentration is the same. Reset. Vomit again. Put it in here. Add the water. Again, now you've got a pH, let's do 1 liter, of 2.3. What if we drain the entire thing of vomit and water? What do you think the pH will do? Again, it's a fixed ratio, stays the same. Go to battery acid. No, not bad. Let's do hand soap again. pH of about 10. Let's dilute it up to 1 liter. So we're diluting it. We reduce the pH slightly. Drain it. Again, both things are leaving. The concentration stays the same. Okay, let's go a little higher level. Let's do battery acid. So now let's add, well, let's see, can I get more battery? Okay, let's add more battery acid. Again, the pH is staying the same, right? Let's add some water. Again, there won't be much pH shift because I only added a very little bit of water. What happens when I drain it? The pH stays the same. Add more water. Now you've diluted whatever was left. See how that works right there? Okay. Let's go with blood. Let's do coffee. Slightly acidic. Take some out. pH still the same because you're removing the ions and the water at the same time. Let's dilute it to 1 liter. Come on. There you go. 5.39. Again, let's take it out. pH stays the same. Okay. All right. So I think we did a pretty good job with that. I don't want to go this far. I think you have an idea. Okay. So again, when you take a look at this, water is neutral. Spit is barely basic. Blood is basic, slightly basic. Hand soap is very basic. has all the properties of a base. Drain cleaner, very strong base, dissociates completely. Whereas these guys down here, from milk on down, milk is slightly acidic. Chicken soup, a little more acidic. Battery acid, extremely acidic. Okay, so that's another way to look at acids and bases. Okay, I'm going to hit stop record, and we're going to